Today we're going to be finishing the back side of the third set of notes, and we are going to be doing letter A and C, still solving radicals, but now we're going to talk about solving radicals when the variable is on both sides of the equal sign. So on the back side of the third set of notes, letter A, notice we have the square root of x plus 7 minus 5 equals x. So now we have variables on both sides. And to solve a problem like this, the goal is to always isolate the variable first as much as possible. So we are going to add the 5 over to both sides first. So I have the square root of x plus 7 equals the quantity of x plus 5. And to get rid of the square root, we would raise both sides to the second power. And again, when you are raising something to the second power, this quantity, we can think of this as 2x plus 5. So I'm going to write x plus 5, x plus 5. And on the left-hand side, we're just left with x plus 7. So on the right side, you either need to FOIL, or for those of you who do the box, go ahead and multiply out these two binomials. So if I did x times x, I get x squared. And then I'd have plus 5x plus 5x plus 25. So I get x squared plus 10x plus 25. On the left-hand side, I get x plus 7 still. So if you did the box, you should still get that. Now, in order to solve, it has to be equal to 0. So we are going to subtract the x from both sides, and we're going to subtract the 7 from both sides. So I'm going to flip the screen so I have some more room. So my middle term, we have 10x minus x. That will give me a 9x. And the 25 minus 7 will give us 18. So we're at 0 equals x squared plus 9x plus 18. And now we need to find two values that multiply to be 18 and add to be 9. So essentially we're factoring here. So my combination that will multiply to be 18 and add to be 9 will be a positive 6 and a positive 3. So if you use the factoring method or if you use the box method, go ahead and figure out what the quantity factors down to be. So if you don't use the box method, it'll look like x squared plus 6x plus 3x plus 18. For those of you who do the box, those four terms would be inside your box. And we group the first two, group the second two to figure out what we can take out. So for the first time, I can take an x out, and I'm left with x plus 6. Second quantity, I can take a 3 out, and I'm left with an x plus 6. So it breaks down to be x plus 3 and an x plus 6. So my two answers are equals a negative 3 and a negative 6. Now, notice in the directions it says check for extraneous solution, so we need to take this and plug it back into the original problem to figure out which quantity is the correct answer. So I'm going to go to the next screen and show you how to do the check part of it. Yes, you must do the check part of it because typically one answer will work, one will not work. Will that always be the case? No. You always need to check both and determine which is the solution and which one is extraneous. So, if I checked the negative 3 first, so we'll check the negative 3, and we'll also check the negative 6. So everywhere I see x, I plug in negative 3. So I have negative 3 plus 7 minus 5 equals negative 3. So underneath the square root, we get 4. Square root of 4 is 2, so negative 3 equals negative 3. So a negative 3 worked. Now we'll check the negative 6 just to be safe. So I have negative 6 plus 7 minus 5 equals negative 6. So underneath the radical, we get the square root of 1. And the square root of 1 is 1. 1 minus 5 is negative 4. And negative 4 does not equal negative 6. So this answer is our extraneous solution and did not work. So that's letter A. So now we're going to skip down to letter C. And letter C is a little bit more difficult. First thing that we're going to do is move that first radical over to the right-hand side. So we're going to move this square root of x over. I'm going to add that over. So now I'm at 2x plus 1 equals the square root of x plus 1. And to get rid of the radical, we're going to raise both sides to the second power. Notice the right-hand side, it is the quantity. So I put it in parentheses because it is the quantity raised to the second power. So on the left-hand side, I have 2x plus 1. And on the right-hand side, I'm going to rewrite this a second time. So for those of you who do the box, those two values go on the outside of the box. If you don't do the box, you're going to go ahead and FOIL. My first term, so the square root of x times the square root of x is the square root of x squared, which would cancel. So that means I'm just left with x. And then the square root of x times 1 is 1 root x. Then I have another 1 root x plus 1. So we have 2x plus 1 equals x plus 2 root x, because those are like terms, plus 1. And notice I still have a radical, so eventually I'm going to have to square both sides again, but before I do that, I want to get rid of that x and this 1. We want to move that over, always isolating the radical as much as possible, so they're canceling. So we are at x equals 2 root x. I'm going to switch screens so I have more room, but essentially, again, I need to raise both sides to the second power to get rid of that radical. So I'm at x equals 2 root x, and to get rid of the radical, I'm going to raise both sides to the second power. So by doing that, on the left-hand side I have x squared. On the right-hand side, I could write it out twice so you could visually see it. So 2 times 2 is 4, and a root x times a root x would be the square root of x squared. So the square root of x squared, and they would cancel, and I'm just left with x. And now I need to move everything over on one side, so I'm going to subtract that 4x over. And I get x squared minus 4x equals 0. And I can't really factor here, but I could take out a GCF, and my GCF is x, and I'm left with an x minus 4. So from this, we're going to obtain that my two answers are 0 and a positive 4. But again, now we need to do the check, and we need to determine which answer works and which one does not. So we need to figure out the actual solution to the problem. So to do the check, we're going to check a 0 and a positive 4. So I'll check my 0 and my 4. So if I plug 0 in everywhere, we have x. We have 2 times 0 plus 1 minus the square root of 0 equals 1. So underneath the radical, 2 times 0 is 0. 0 plus 1 is 1. Minus the square root of 0. Square root of 1 is 1. Square root of 0 is 0. So 1 equals 1. So that checks out. So 0 is definitely a solution. Now we'll check 4. So I have 2 times 4 plus 1 minus the square root of 4. And we're trying to determine if this equals 1. So underneath the radical, 2 times 4 is 8. 8 plus 1 is 9. So I have the square root of 9 minus the square root of 4. So I have 3 minus 2. And 1 equals 1 again. So 4 is also a solution. So again, don't think that you always have to have one solution, one extraneous. Sometimes they both work. So that is all for today.